Hi, welcome back to Imagine Planet. On my shoulder here is Callie. She is our Mexican redheaded Amazon parrot. She's a little smaller than our other Amazon parrots. She came to us some time ago with a friend, a cockatiel friend. The cockatiel friend has since unfortunately passed away. They don't live as long as the Amazon parrots. So, right, Callie? Okay. So Callie today is going to listen to Baby Mammoth Mummy, Frozen in Time. This is really cool. A Prehistoric Animal's Journey into the 21st Century by Christopher Sloan. All right. The Discovery. Here's a picture of Siberia. All right. Siberia's Nenettes are nomadic reindeer herders who have learned to survive winters that can plunge to minus 76 degrees Fahrenheit or negative 60 Celsius. The whoosh of a sled pulled by reindeer sliced through the stillness of a snowy plain in Siberia. It was May. The tundra was still frozen, but in a few weeks it would begin to thaw. Yuri Kuti and his sons glided along the bank of the Urubay River. They were taking advantage of the good weather to do some hunting. Perhaps they would spot a game bird or other small animal that would add some variety to a diet of fish and occasional reindeer meat eaten by the Nenettes people who have herded reindeer in Siberia for more than 800 years. The last thing Yuri expected on this outing was that he would make an important scientific discovery. All right, baby mammoth, lost and found. From a distance, it looked like a dead reindeer lying on a sandbar along the river channel. As Yuri drew closer, however, he thought it looked more like a baby elephant. How could that be? The nearest elephants lived thousands of miles away. As Yuri and his sons stood around the little body lying on the sandbar, they were shocked by what they had found. A perfectly preserved baby woolly mammoth. It was frozen solid. These animals disappeared from this part of the world about 11,000 years ago, but mammoth bones and tusks are a relatively common find in Siberia. It's so cold in this Arctic region of Russia that the frozen soil, called permafrost, has acted as a giant freezer, preserving the carcasses of many animals that lived there long ago. As the top layer of permafrost begins to thaw in the spring, the bony remains of mammoths often appear as if they have burst from the frozen ground. But Yuri and his sons had never seen anything like this before. A baby woolly mammoth with all of its flesh in place. It looked like it could have died yesterday. They didn't dare touch it. And this recreation illustrates what a mammoth carcass would look like as it emerges from the permafrost during a spring thaw. That's this right here. Not sure how good that turned out. The Nenettes' frozen homeland was once an endless plain of grasses and shrubs called steppe, shared by woolly mammoths and other prehistoric grazing animals. Nenettes keep warm in chums, teepee-like huts made of reindeer hide. Reindeer hide is also often used for clothing, such as boots, parkas, and other outerwear. There's a picture of a family here. Oop. Having trouble. There we go. All right, life at the end of the earth. Yuri and his sons belong to the ancient Nenettes culture, which has inhabited the Yamai Peninsula of Siberia in northern Russia for more than 800 years. Yamai means, or Yamal, means end of the earth in the Nenettes language. It's a fitting name for the strip of land that stretches north into the Arctic Ocean to within 1,500 miles of the North Pole. The 40,000 or so Nenettes living on the peninsula are nomadic herders who depend on reindeer for survival. They rely on the animal's meat for food and sell it for income. They also use the thick skin to make warm parkas, boots, and large circular tents called chums. During the 9-month-long winter, the Nannettes camp in these tents surrounded by their reindeer. There is no electricity and no telephones, and the only water comes from ice after it is melted. In the spring, the Nannettes move to pastures where their reindeer can graze on fresh green shoots of grasses and shrubs. Siberia takes up more than 3/4 of Russia's land area, but contains very few of its people. Mammoth remains are found throughout its northern parts. Lyuba's journey started on Siberia's Yamal Peninsula. Insect. So here is a picture of Russia, and this fits right there. So this is the peninsula. It fits right there. Mammoths play a powerful role in Nanette's mythology. The story goes that woolly mammoths are giant beasts herded by gods of the underground. If the animals come to the surface and see sunlight, they die. Some Nannettes say that mammoths will bring bad luck or even death to the people who touch their remains. So it was with both fear and respect that Yuri Kuti and his sons looked at the baby mammoth. Uncertain what to do, they left the mammoth exactly where they found it and returned to camp. Yuri decided to seek the advice of Kirill Seroteto, a trusted friend who had lots of experience in the Arctic as an expedition outfitter and knew the value of mammoth bones. To get to Yar Sale, or Sale, we're going to go with Yar Sale, where Seroteto lived. Never let pronunciation keep you from reading out loud. Yuri rode his snowmobile 90 miles to Navi Port, then boarded a helicopter to Yar Sale. After hearing Yuri's story, Seroteto rushed him to the director of the museum, who notified the local police. Yuri had stumbled onto something big. Hours later, Yuri, Seroteto, and a few policemen were flying toward the place where Yuri had made his discovery. Finally, they landed near the site. The baby mammoth was gone. Yuri's stomach dropped. He was afraid no one would believe him now. Without a body, there was no reason for the police to stick around, so they flew back to Yar Sale. Seroteto stayed behind with his friend to investigate further. Yuri knew that prehistoric animal remains, especially tusks, were valuable and could fetch a lot of money from fossil collectors or carvers. After making some inquiries, he and Seroteto learned that Yuri's cousin had snatched up the baby mammoth and carted it off on his sled to Novi Port. There he had traded the valuable find to a store owner in exchange for 2 years' worth of food and some equipment. Yuri and Seroteto had to move fast if they were going to save this precious treasure. By the time they arrived in Novi Port, the little mammoth was propped up in the store and was already causing a stir. People were taking pictures of it with their cell phones. Yuri's heart sank when he saw that stray dogs in town had already gnawed off the baby's tail and most of one ear. But the rest of the body was still in perfect condition. You didn't have to eat my ear. Ow! They had to get the mammoth to a safe location first. Seroteto, with the help of the local police chief, explained the importance of the find to the owner. Finally, after much discussion, he agreed to give up the mammoth. Here, Bernard Wiguez uses a laptop to show Yuri and his family photographs taken for a television show about the baby mammoth. The stolen mammoth. Oh, here's the story. Nanette's myth, as told to Bernard Wiguez by a friend of Yuri Kuti. Once upon a time, there were 2 gods, the god of above and the god of below. The god of above had 4 sons, and the god of below had 7 sons. One day, the 2 elder sons of the god of above killed a mammoth that belonged to the god of below. They ate its flesh for 7 days and were well nourished, as there was much meat. They threw the mammoth's head into a lake to hide the fact that they'd killed it. Soon it happened that the 7 sons of the god of below went to fish in the world of the above. They also went to see the sons of the god of above to ask if by chance they had seen their mammoth. The sons lied and answered that they had not. When the 7 sons of the god of below started fishing, however, the lines they cast into the lake snagged the mammoth's head. Having discovered the truth, they returned to the sons of the god of above and challenged them. They said you hadn't seen our mammoth, but in fact you ate it. When the 7 told their father what had happened, the god of below declared war on the god of above. His 7 sons attacked the god of above, who called to his sons for help. Thus the war between the above and the below started. The 2 elder sons of the god of above hid in their father's ear. Okay, she doesn't hear. I'm not going to bite my ear. And fired shots at the god of below, but they could not defeat him. The god of below then called on his younger sons and asked them to help in the violent war. These sons hid in the mouth of their father, and from there they launched flames of fire at the god of above. In the battle that followed, 4 sons of the god of below died, leaving only 3. The god of below asked the god of above for mercy, saying, "You've already killed 4 of my sons. Let us stop this war. Let's make peace by having our children marry." So the 2 younger sons of the god of above married the daughter of the god of below. She brought fire from the world of below to the world of above, and this is how the peace was made. Native people of Siberia use most of the mammoth ivory they find to make tool handles, parts for reindeer harnesses, and other useful items. Big tusks, like the one strapped to this reindeer sled, are sometimes sold to collectors or carvers. Safe and sound. At last, the baby mammoth was in the hands of museum staff at Yarsail. Now they needed to find a place where she would be preserved and taken care of. The calf was packed onto a helicopter and flown to the Shemenovsky Museum in Saligard, a regional capital of Siberia. The director there immediately called Bernard Bruguier, a French explorer who had become an expert in mammoths and who had established a center for preserving mammoth remains in the Siberian town of Katanga. When Bernard heard the exciting news, he offered to organize an international team of experts to study the baby mammoth. The team would include research from Russia, the United States, and Japan. It would take several weeks for the team to assemble in Saligard. To keep the carcass frozen, it was placed in a freezer. Bernard was the first member to arrive. When he saw the baby mammoth, he was struck by how tiny she was, only 33 inches high and 110 pounds in weight. I was just fascinated by her lifelike expression. Her smiling mouth, her front legs seemingly in motion. It was as if she had been enjoying herself. He couldn't wait for the rest of the team to meet her. Here's a reenactment of her going in the helicopter. You can see how big she was. Mammoths, mastodons, elephants, and more. All elephant-like creatures. Here's a picture here. We'll start with that. Wow, that's a lot of different elephants. All right. Including mammoths are part of the order Proboscidea. Today, elephants are the only living proboscideans, and they include just 3 living species: the African bush elephant, the African forest elephant, and the Asian elephant. In prehistoric times, however, there were many types of proboscideans, including mammoths, mastodons, which lived in North America at the same time as mammoths and looked much like them, gomphotheres, many of which had 2 upper and 2 lower tusks, and stegodons, a group of elephant-like animals that ranged from 13 feet high at the shoulder to a dwarf species that stood only about 4 feet high. A proboscidean gets its name from its long, sensitive, muscular nose, called a proboscis, which it uses to grip food. Different groups of proboscideans had different tusk and trunk arrangements, as shown in the art at right. To identify a specific proboscidean, match its number with the number and name on the chart below. We're going to give this a try here and see how good we can get this in here. So let's see. Number 1. If you can identify it with its number. I think that's got to be Moetherium. Oh, there. Okay, the numbers are here. We don't have to figure that out. Phew. And then this. Okay, Dinotherium. And number. Oh no, that's number 5. That's Dinotherium. 3 is Paleomastodon. Let's see, number 4, Mammut, which is a mastodon. And number 5 is Gomphotherium. 6 is Stegodon. 7, Primeelephas. 8 is Mammutus, which is the mammoth. And 9 is Elephas, the Asian elephant, and Loxodonta is the African elephant. So here's those numbers and what they are. Let's see, that is definitely not coming into view there. Well, guess you'll have to come to a Magic Planet and look at the book. All these books, when we open again, will be available to check out, to look at, not to take from here. The Investigation, Chapter 2. Layuba became the subject of a series of intense investigations that involved a variety of state-of-the-art equipment and travel to several cities. So here's a picture of her. Okay. The neat thing is that this journey has a local element to it. News of the baby mammoth was starting to spread around the world. Some reports even called her the world's most valuable discovery. Bernard's team of experts, which included Alexei Tikhonov, vice president of the Zoological Institute in St. Petersburg, Russia, and Dan Fisher, of the University of Michigan, could hardly contain their excitement as they waited to get their first look at the prehistoric creature. Yes, Dan Fisher. He was a professor when I was going to grad school at the University of Michigan. And I've seen him since then. He's also the same person who worked on the Mastodon in Chelsea. So, rare opportunity. They stared in amazement as they gazed at the best preserved baby mammoth they had ever seen. She was missing most of her shaggy hair, toenails, and the shoot-off bit of tail and ear, but other than that, she was completely intact. Before the team's arrival, officials at the Shemenovsky Museum had decided to name the little calf Layuba, after Yuri Kudy's wife. The word, which means love in Russia, seemed fitting for this charming visitor from the past. Everything about Layuba was a mystery. When did she live? How did she die? What caused the strange dent in her face just above her trunk? And what secrets could she reveal about her prehistoric world? The team would have to draw on their own skills and those of the other experts at state-of-the-art research facilities around the world to uncover the truth about Layuba's life and death. Layuba was extremely well preserved, but her stumpy little feet, like the one shown here from the bottom, had lost their toenails and she had very little hair left on her body. The team got its first look at Layuba at the museum in Salikard. She was undamaged except where the dogs at Navi Port had gnawed off her tail and right ear. So here we go. I think we've all seen this picture already before. Investigation 1, Groningen, Netherlands. Mission: find out when Layuba lived. Woolly mammoths lived from about 800,000 to 3,700 years ago. But the scientists wanted to know when, during that time, little Layuba roamed the plains of Siberia with her mom. So the teams took a tissue sample from her body and sent it to a laboratory in the Netherlands. There, experts used radiocarbon dating to find the answer. All living things contain the element carbon. There are different forms of carbon known as isotopes. One isotope of carbon is carbon-14. Over time, it changes to nitrogen-14. The age of a specimen can be determined by finding out how much of the carbon-14 has changed to nitrogen-14. The results showed that Layuba lived 42,000 years ago. Wow. Then, investigation number 2, Tokyo, Japan. Mission: look inside Layuba. The scientists were anxious to see if the inside of Layuba's body was as well preserved as the outside. This would require a special 3D X-ray machine called a CAT scanner, or CT scanner. Naoki Suzuki, another member of Bernard's team, had one in his laboratory in Japan. The team knew that transporting the mammoth that far would be risky. Layuba had to stay frozen or she would start to decompose. Keeping her frozen and clean would also help protect her body from mold, bacteria, and other unwanted organisms. Plus, it would ensure that any ancient bacteria or viruses she might be carrying didn't endanger her human handlers. So the scientists came up with an elaborate plan. In Japan, Lyuba was placed in a specially built container and carried through sterile plastic tunnels to the research laboratory. Really? They packed the baby mammoth in a sealed plastic bag, placed her on top of bags of dry ice in an insulated box, and loaded her onto an airplane. Her arrival at Tokyo's Jikai University School of Medicine was like something out of a science fiction movie. The scientists who greeted her looked like astronauts, wearing face masks and covered from head to toe in sterile suits. Here we have the... And the masks were there to give them oxygen in case carbon dioxide had been given off by the dry ice. That makes sense. Bernard's team of experts opened the insulated box and peered anxiously inside. Much to their relief, Lyuba was still frozen and had survived the journey undamaged. They carefully transferred the baby mammoth to a special container that would fit inside the CAT scanner, lifted it out of the van, and carried it through a clear plastic tunnel straight into Suzuki's state-of-the-art laboratory. The team wasted no time in placing the container holding Lyuba on a sliding platform that would move it through the CAT scanner. CT scanner, I should say. This machine would create multiple X-ray images of Lyuba that could be put together by a computer to show the inside of her body in 3D. The images showed different densities of bone, organ, and other tissue. This way, the scientists could see into Lyuba without cutting into her body. The scans showed what the scientists hoped they would. Lyuba was almost as well preserved inside as she was outside. Her heart, stomach, intestines, and lungs were all about where they should be. But the scans also showed that something was wrong in Lyuba's trunk and throat. These passageways, which should have been clear so that she could breathe, were filled with a dense substance. The researchers were excited. Had they discovered a clue to what had caused Lyuba's death? Suzuki and Fisher saw some other mysterious things on Lyuba's CAT scans. Some areas appeared to be covered with some sort of fine-grained material, and small areas inside some of her bones showed up as bright spots on the scans. The only way to find out what these things were and what was blocking the calf's trunk and air passages was to go inside Lyuba's body, using some of the same tools a surgeon does when operating on a patient. But this was a job for another lab. There they are in Japan. Now, next investigation is to perform a mammoth autopsy in St. Petersburg, Russia. Before long, Lyuba was back on an airplane in her traveling freezer and on the way to a genetics laboratory in St. Petersburg, Russia. Fisher, Bernard, and Suzuki joined paleontologist Alexei Tikhonov at the laboratory a few months later. Together they would carefully open up Lyuba's body. For them, it would be like opening a treasure chest. They didn't know what they would find, but expectations were high that the examination would not only tell them about Lyuba's life and cause of death, it would also open up a window into life on Earth 42,000 years ago. The autopsy would take 3 days. Once again, they put on sterile outfits and surgical masks and began their examination. Prehistoric secrets lay just under their fingerprints. Their challenge? To cut Lyuba open and sew her back up with as little damage as possible. That way, Lyuba would be preserved for studies by other scientists and future generations. Healthy fat. The scientists' first task was to inspect the hump on the back of Lyuba's neck. The mammoth experts wondered if the creatures stored extra fat in their humps to help them survive long, cold winters, and if so, how long it took to build up a supply. Really? Wow. Based on the amount of fat they found in a pencil-thin sample from Lyuba's hump, it appeared that well-fed baby mammoths born in late winter or early spring were rapidly building fat reserves for the following fall and winter. Researchers also looked into Lyuba's ears for mites, tiny bugs that live in the ears of many modern mammals, and other microscopic creatures that might have existed in Lyuba's prehistoric environment. Here's a picture. They snipped off little bits of woolly hair from Lyuba's legs. The hair, if it had not been too damaged over time, might still contain some DNA, the material that contains hereditary information about an organism. Within the DNA, researchers might be able to find genes, the specific genetic material that makes a mammoth and a mouse a mouse. With a great deal of luck, scientists might be able to piece together genes from many strands of DNA to make a complete genetic map called a genome. Suzuki placed an endoscope, a narrow tube with a camera lens on the end, into a small hole he made in Lyuba's side and guided it through her insides by looking at a computer monitor. The team could see that the fine-grained substance revealed by the CT scan was blue. Fisher recognized it as vivianite, a mineral produced in part from the mineral phosphate, which occurs naturally in bones and soft tissue. Earlier, the scientists had found vivianite on her skin, especially on the side that had rested on the sandbar. They suspected that the same mineral caused the bright spots in some of Lydia's bones. But why was there so much of it inside her body? Got some more pictures here. That one's kind of gross. And here, we're going to read about how she died, I think. There. Trunk trauma. White areas on the CT scan are bones and other dense substances. This image shows that something is blocking part of her trunk. A researcher uses a toothbrush to collect mites and other tiny organisms that might have been preserved in Lyuba's ear. Trunk trauma. Further dissection and probing with an endoscope revealed that mud was blocking Lyuba's trunk and air passages. In all likelihood, the baby mammoth had suffocated in thick muck as it plugged her air passages before reaching her lungs. The mud was probably the source of the layer of vivianite in her body, and it also might help explain the odd dent in her face. When Lyuba sucked mud into her trunk, she tried to dislodge it by inhaling sharply, but this pulled the mud straight back into the air passages near her lungs and blocked them. As the mud was sucked out of her trunk into her air passages, a vacuum was created. This collapsed the soft tissue of her trunk and created the dent. With some of their biggest questions already answered, the team was anxious to see what other mysteries the autopsy would solve. And this picture, is an artist's depiction, shows little Lyuba struggling for air while her mother and other mammoths in the group look on helplessly. Scientists suggest she drowned or suffocated in mud. Oh. From what we know about elephants, this would have been very traumatic to the herd. Last meal. Fisher made a square cut in Lyuba's side so he could reach her intestines to see what she had been eating. Amazingly, they still contained the 42,000-year-old remains of her last meal. The researchers found traces of the mother's milk that Lyuba had nursed on the day she died. They also discovered that the calf had been eating her mother's dung, something that baby elephants do. Mother elephants pass bacteria to their calves through their dung. These help the babies digest plants once they stop nursing. It was exciting to find this link between mammoth and elephant behavior, but there was more. The dung would also reveal what kinds of plants Lyuba's mom had been eating, which could lead to new information about the vegetation that existed in Siberia tens of thousands of years ago. All right, so here's Sealed in Time. Lyuba's 42,000-year journey to our time began when she suffocated in mud or drowned in water and was covered over. Microbes in Lyuba's wet grave penetrated her body and stopped her corpse from decaying. Soon, Lyuba's moist environment became locked in a layer of permanently frozen soil called permafrost. Erosion caused by the rushing waters of a spring ice melt freed Lyuba from her frozen tomb and washed her downriver where Yuri discovered her. Telltale smell. Cutting into Lyuba's slightly thawed body to get samples had released a distinct sour odor that reminded Fisher of an experiment he had made several years earlier. From his studies of mammoth finds in North America, he noticed that their bones were often discovered in places once covered by water. Had ancient hunters stored mammoth carcasses in ponds? To see if this method of food storage would work, he sank large chunks of raw horse meat in water for several months. When he tasted the meat, he found that it was still edible. Microbes had prevented decay and in the process had reduced a sour smell, the same odor coming from Lyuba. Fisher realized that Lyuba had been pickled by the microbes in the wet environment that surrounded her after she died. This had prevented her from rotting and likely had made her body smell unappetizing to scavengers. The autopsy had solved many mysteries, but still unknown was Lyuba's age when she died. Fisher knew where to find the answer, in her tusks and teeth. He carefully extracted one of her tiny milk tusks and a cheek tooth, or premolar, to take back to his lab in the United States. Investigation 4. Ann Arbor, Michigan. Find out how long Lyuba lived. Tusks start growing in a baby mammoth's mouth before it is born. These tusks are replaced by permanent tusks that keep growing until the day the animal dies. They grow a little longer each day as a new microscopic layer of dentine is added. Dentin is what makes up most of the tusk. By cutting Lyuba's tusk in half, Fisher could count the layers of dentin like the growth rings in a tree trunk. But how would he know where to start counting? Earlier studies of another baby mammoth showed that the stress at birth is recorded in the tusk as a darker layer of dentin. The same thing has been observed in some other animals, including humans. This marks the first day of life. Fisher found a similar marker in Lyuba's tusk. He counted 32 layers, confirming that Lyuba was 32 days old when she died. So here's the picture like a tree trunk here. Chemical clues. Much of what we know about mammoths and their environment has come from their tusks. Hidden in the dentine layers are chemical traces of the food they ate. By studying the makeup of tooth material, scientists can determine what food sources were available at the time and how well the animal was doing in its environment. Combining this sort of detailed information about mammoths with findings about other prehistoric animals, plants, and climate makes it possible for Fisher and other scientists to reconstruct the Ice Age world and suggest reasons for the mammoth's extinction. Lyuba's tiny milk tusk promises to reveal new information about how mammoth biology compares with that of living elephants. How do we know how old things are? It's a pretty big thing, so I can't tell if you can read it. But we've got one of the first questions researchers who study prehistoric life ask is, how old is it? Scientists now have many ways to answer that question. Accurate ages can be found by looking at the sequence of geological layers, flip-flops in the magnetism of Earth's poles that are recorded in rocks, and at the decay of radioactive particles trapped in rocks or even in animal or plant tissues. Life on Earth is more than 3.5 billion years old. Compared to the time of dinosaurs, Lyuba lived just moments ago. How long ago did Lyuba live? Scientists can tell when an animal lived by measuring how much carbon-14 in a sample of the animal's tissue compared to how much is in the atmosphere today. From the moment of death, half of the animal's carbon-14 starts to decay. Over spans of 5,730 years, half of the carbon-14 present decays into nitrogen-14. The chart below shows how scientists know Lyuba died 42,000 years ago. This dating method can be used on samples up to about 60,000 years. There's the percentages. Let's see if I can get that. There we go. You can pause it if you want to look at that more carefully. There's a few other time things there. Earliest modern humans, 195,000 years ago. All right, woolly mammoths, with their bulk and large appetites, played an important role in shaping their environment, called the mammoth steppe. So this is Chapter 3, Lyuba's World. The landscape of the Yamal Peninsula of Siberia, where Lyuba was discovered, looked completely different when the baby mammoth lived there 42,000 years ago. Lush grasslands called steppe flourished where icy tundra exists today. It teemed with millions of animals, mammoths, steppe bison, and a variety of smaller creatures. During the spring, soon after Layuba and all baby mammoths were born, the area was a sea of flowing green grasses with rivers, bogs, and lakes dotting the landscape. When spring comes to Siberia's Yamal Peninsula, ice and snow melt quickly, revealing a pattern of rivers and bogs similar to what might have existed on parts of the mammoth steppe. The crowd of animals on the mammoth steppe can be compared to that on the Serengeti in East Africa today. The mammoth steppe, this is this picture, burst with green in late spring, much like the Siberian steppe below does today. Almost all mammoth steppe plants still grow on the Yamal Peninsula and other areas. Oh. For mammoths and other plant-eating animals, the steppe was an ideal place to breed and raise their young. There was plenty of food and water, and large family groups provided safety in numbers. But danger always lurked nearby. Anywhere mammoths lived, carnivores such as cave lions, gray wolves, brown bears, hyenas, and wolverines were not far away. If Layuba had strayed too far from the safety of her mother's side, she would have been easy prey. Layuba was so young that she survived solely on her mother's milk. But older members of her family group would have feasted on grasses, shrubs, and grass-like plants called sedges during the short summer growing season. But young and old alike had to prepare for the long, cold winters. Building up a store of fat, just as Layuba did in her little hump, might make the difference between life and death. Layuba's hair would have been growing longer. Pressing up against her mother's big, hairy body could provide some protection from the cold winds that would come with winter. But the baby would need a coat of her own. Like all woolly mammoths, she would have an undercoat of fine yellowish-brown wool to keep her body warm and dry, and an outer layer of shaggy hair. This would have been either dark red, brown, rusty red, or even blonde, and would have provided extra protection by trapping air between the two layers of fur. All right. Other parts of a mammoth's anatomy helped the animals survive in a cold environment. Unlike today's elephants, which have large ears that they can flap to cool off, woolly mammoths had tiny ears. The small size of their ears, plus the fact that they were covered with hair, helped keep heat inside their bodies. Woolly mammoths had an overall shorter, stockier build than other mammoths. This meant that less of their bodies was exposed to cold air, and layers of fat under their skin helped keep them warm. Woolly mammoth tusks were huge compared to their stocky bodies. The animals may have used them to sweep aside snow so they could munch on the edible plants underneath. Adult males probably lived separately from females and their young, except during mating season, when large males would come back to the family group. Male mammoths likely used their huge, spiral-shaped tusks, which were as thick as tree trunks and sometimes grew to more than 14 feet, to battle other males and attract females. Here we have modern human hunters with Stone Age technology coexisted with woolly mammoths for tens of thousands of years in Europe and Asia before the animals became extinct there. In North America, the time between the arrival of hunters and the time that mammals became extinct was much shorter. It says a key to mammoth survival was having blood that could carry oxygen to cells at very low temperatures. Why did mammoths disappear? These yearly rituals played out for thousands of years on the mammoth steppe, which once stretched across land masses in the northern hemisphere from the British Isles to North America. But this world would not last forever. When tiny Layuba was born 42,000 years ago, millions of mammoths roamed Earth's northern grasslands. By 10,000 years ago, mammoths had disappeared from all but the most remote areas of Siberia and a few isolated islands off its coast. They had completely vanished by 3,700 years ago. What caused them to become extinct so quickly is still a mystery. There are several theories, but the two most likely involve climate change and hunting. Oh, here's a thing about climate change. Over the last 500,000 years. See the chart there? All right. Woolly mammoths survived many ups and downs of climate over hundreds of thousands of years. They were extinct in most places 8,000 to 15,000 years after the rapid thawing of the last glacial maximum. One of the Earth's coldest climates in the last million years occurred about 20,000 years ago. During this time, known as the last glacial maximum, a polar ice cap stretched from the North Pole all the way down to the Great Lakes of North America. Many places in Europe and Asia that seldom see snow today were covered with deep icy glaciers. Within another 10,000 years, a short time in geological history, Earth was warm like it is today. Such rapid climate change would have had a dramatic impact on Earth's ecosystems. The mammoths and the environment that sustained them may not have survived these sudden changes. But some scientists think climate change may have been only one part of the story, or may not have been part of the extinction process at all. I do want to say something about that graph there. It does not show what it isn't to scale there. Okay. It looks like the present is as hot. It's been this hot before, and it hasn't in the last 500,000 years. So, just throwing that out there. Not that climate change now affects the mammoths. Oop. Climate chaos. A polar. Okay, I went back. Sorry. Hunted to extinction. When modern humans first reached the northern parts of Europe and Asia about 45,000 years ago, mammoths were still thriving. These Stone Age hunter-gatherers used tools made of stone and survived by hunting animals and collecting edible plants as they moved from place to place. Stone Age campsites unearthed in Europe and Asia are littered with mammoth bones, as well as stone tools and weapons. By studying evidence from such sites, scientists have learned that these Ice Age people ate mammoth meat and used mammoth bones, tusks, and skin for tools, clothes, and shelter. They even used the dung for fuel and to keep warm. Mammoths were important to their survival. These humans may have followed the mammoths into North America, crossing the Bering Land Bridge that connected Siberia and Alaska at that time. The area, now called the Bering Strait, is underwater today, but during the Ice Ages things were different. So much of the world's water was locked up in the polar ice cap and glaciers that sea levels dropped enough to expose land usually covered by water. This mammoth figurine, perhaps a pendant or a necklace, shows that Stone Age people used mammoth bones and ivory to make more than tools, needles, and other practical things. So this is a mammoth-shaped piece of art. Some researchers think Stone Age people rarely hunted mammoths because they were so difficult to kill. Instead, as shown here, they scavenged dead ones for meat, hide, and ivory. The woolly mammoth was the last surviving mammoth species to walk on Earth. By 12,800 years ago, the mammoth population in North America was on the brink of becoming extinct. The last known mammoths on Earth lived on Wrangel Island, off the northern coast of Siberia, about 3,700 years ago. Scientists have found evidence indicating that this is the same time period that humans arrived on the island. But there is no evidence to show that humans were killing mammoths in large enough numbers to cause their extinction. That is why many scientists think it was a combination of climate change and hunting that caused mammoths to disappear. But since no one knows for sure, some researchers have looked for other explanations. Deadly disease. Animals living in a world populated by humans, or humans themselves, may have brought diseases with them when they crossed the Bering Land Bridge from Asia. This could have caused a deadly epidemic among mammoths already in North America. But some researchers object to this idea. They point out that several animals in a population usually have immunities that would allow them to survive an epidemic. Interesting thought right now, isn't it? Extraterrestrial explosions. Some researchers suggest that a large object from outer space, possibly a meteoroid or comet, exploded in the atmosphere over North America around 12,900 years ago. Such an event could have triggered a sudden cool period that lasted for the next 1,300 years, disrupting environments and perhaps driving many species to extinction. They argue that a dark layer of earth found at archaeological sites comes from ash left by widespread fires caused by the explosions. They also say that tiny diamonds found in microscopic particles in that layer could only have come from outer space. Opponents say that such particles are always raining down on Earth from space and that the scorched Earth came from normally occurring forest fires. Could a perfectly preserved baby woolly mammoth help answer one of the biggest mysteries on Earth? Why did mammoths become extinct? Since she lived well before the extinction, she probably can't shed much light on that mystery. But thanks to new technology, mammoth mummies might be able to help in another way. Their DNA could provide scientists with what they need to recreate this Ice Age giant. Here's the fire, the extraterrestrial thing hitting. All right. Will mammoths live again? Some say yes. Hendrik Poinar, an expert on ancient DNA, goes so far as to say that it is just a matter of working out the details. Researchers have made clones of sheep, pigs, and many other animals, and one day they could clone a mammoth. By stitching together tiny pieces of ancient DNA that come from the tissue of well-preserved mammoths, such as Lyuba, scientists hope to one day recreate a complete mammoth genome. Similar to the way animals are cloned today, the recreated mammoth DNA could replace elephant DNA in an elephant egg. If the egg grew properly, the mother elephant would give birth to a baby mammoth. Today, researchers are also trying to recreate the mammoth steppe. They are introducing large animals, such as reindeer and musk oxen, to a park in Siberia. The hope is that over time, these big animals, by keeping plants cropped low and fertilizing the soil, will have the same impact that mammoths and other large Ice Age animals had on their environment. If all goes according to plan, the park could one day welcome home a baby mammoth that would roam the steppe, just as Lyuba did many thousands of years ago. Musk oxen are among the large animals that survived the Ice Age. Researchers hope young musk oxen, like the ones shown here, will help in efforts to recreate a small version of the mammoth steppe. So these guys are musk oxen. Getting there. Thanks for hanging in with me here. Recreating a vanished world. Ice Age animals roam this recreated scene of life in a grassy summer tundra in Alaska more than 500 centuries ago. 50,000 years. Back then, the area was part of the mammoth steppe. As temperatures dropped and the ice advanced over the mountains, and as they encountered human hunters, many animals became extinct. Those that disappeared are marked with a red dot. Unmarked animals or close relatives still survive either in Alaska or in Asia. If scientists succeed in cloning Ice Age animals and recreating their habitat, we won't need a painting to show us what life on the mammoth steppe looked like. We'll be able to see it with our own eyes. So if you can look at this, I'm going to go close here. The red dot are the ones that became extinct. I don't know how that turned out. Prehistoric camel, mastodon, stag moose, great North American short-faced bear. All right, and further reading. And here is a quote from Dr. Fisher here. Oh my goodness, she's perfect. Even her eyelashes are there. Looks like she just drifted off to sleep. Suddenly what I've been trying to visualize for so long was lying right there for me to touch. Paleontologist Daniel Fisher. So you can read up on Dr. Fisher, who is still at the University of Michigan working hard, and the bristly mammoth, which was found here in Chelsea after she was found in 2009. After all that, a lot of neat stuff going on right now. And when that museum opens up, I hope you get a chance to go and see a lot of the neat stuff there. Thanks for sticking with me. 49 minutes. Whew. That was a long book, but I think it was really, really cool. All right. Thanks for watching. Talk to you. And what do you think? Can you say anything, Callie? No. All right. Bye.